I'll talk about GraphSync. And before I get into it, I want to say that it shouldn't be called GraphSync because it's neither about graphs nor about sync. So if at the end of the talk you have a good understanding on what this is about, please propose a better name. So this is the exercise. But now let's get into it, what it actually is about. So we have a system called BitSwap, which is about, so it does a lot of things, but like for this talk, the interesting part is if you want to request data from another peer, what you do is you send a single CID to the other peer and you get a single block back. These days it's even possible to send several CIDs and get several blocks back. But the important thing is it's always a one-to-one mapping. So basically for every CID you send, you get exactly one block back. And I give you an example on what this is used for. So in UnixFS, you send, so you run a file, you send the root CID, you get the root block back. But then you basically parse the thing again on your on the peer that requested it. You look into it, you get the links, you again send several CIDs of the blocks back to the server and get blocks, those blocks back again. And then, of course, if it's like a full tree, which normally is, if you enter a file, you do all those things again. This doesn't sound efficient, and that's the reason for GraphSync. So in GraphSync, what you do is you send a single CID and some meta information. I get more into this later on in 2 minutes. And then you get several blocks back. And what you get with it is, you remember this from like 1 minute ago, this diagram. What we change is we send a root CID and some meta information, and what we get back is all blocks needed, and so you don't need all the rest. So this is why you want GraphSync. And so the metadata is also kind of called IPD selectors. So if you have heard of those, this is kind of exactly this. But in Berlin at the developers meeting, we came up with an idea of basically just making it like a flag and saying it's general metadata, so it does need to be like a nice selector XPath-like, but it could be anything. So for example, for UnixFS, you would just send the, say it's a UnixFS selector and you want to send the offset and the length, and you get the file back. Or it could be like more advanced for better traversals, a full XPath-like thing. Could be a CSS selector, whatever you implement. Right, and the challenges are, so of course peers might only have subsets of the data. So you request several peers, get only a subset back, request the other subset from another peer, but this should also be always, everything of this should be handled really by GraphSync itself, so you don't need to care. If you use it, it will do it automatically. There will be then a guarantee that the returned nodes would be the same as you would do the traversal on a local node. And another challenge is that those selectors, if you implement your own, should be easy to implement. And the biggest challenge is finding a better name. And if you want to know more about it, so I have a draft online with like basically explains all the things with if you work with different peers and how things should work and more on the details. So feel free to go there and like also comment if you think it's a good idea, if I'm missing something or not. Yeah, that's it. Thanks.